Good afternoon, guys. Today we are going to be talking about Unit 10.1, Linear Inequalities in Two Variables. Boy, that's a mouthful, right? So we've already talked about inequalities. Man, I forgot to change the thingamajigger. All right. Already talked about inequalities. Inequalities are three is less than 5. That's an inequality. If we want to do an inequality that we can solve, we can say x plus 2 is less than 5. We subtract our 2, x is less than 5 minus 2 is 3. Right? Inequality, basic, not a problem. Now we're going to be talking about inequalities with two variables. So we have our slope-intercept form. Everybody remembers y equals mx plus b. Remember that? If not, let me refresh you. Y, that is our f of x, or our y-intercept. This is our x-intercept. That's y. Mx, m is the slope. X is your x-intercept, and there is your x-axis. And b is your y-intercept. So if you have something in slope-intersect form, y equals, let's see, let me find a slope-intercept form. Y equals 2x plus 3, right? So then you'll have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 2x plus 3. 0 times 2 plus 3 is 3. 1 times 2 is 2 plus 3 is 5. 1, 2, 3, 4, 5. That's an equal to, though. What does it mean if y is less than 2x plus 3? Well, that means that everything below that line, all of that, that's supposed to be shading, is part of the answer. Does that make sense? So this line is y is equal to 2x plus 3. So if we want y is less than 2x plus 3, then the answer is anything below that line. So that's an inequality. That's how we're going to solve. But we're going to look for groups, just like we've been doing, where we solved for a group of functions, right? Let's see here. Let me flip back. Solve linear systems by adding or subtracting, right? It's one of the last things we did. So we're going to solve linear systems, but we're going to solve linear inequalities. So it's exactly the same thing as we've been doing. The math is almost identical, but instead of an equal sign, we're going to use an inequality. So let me shift this to graph paper and draw some axes. Boop, and boop. Okay. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So 5, 4, 3, 2, 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. This is our y-axis. This is our x-axis. So if we were to plot y is greater than 2x plus 3. Okay, so let's start with x of negative 2. 2 times negative 2 is negative 4 plus 3. 1, 2, 3. Negative 1. 1 times negative 2, or negative 1 times 2 rather, is negative 2 plus 3. 1, 2, 3. 0 times 2 is 0 plus 3. 1, 2, 3. And you can see we have our graph. Right? I'm learning to use this a little bit better to make it neater for you guys. Aren't you impressed? Probably not. So that's our graph. But that graph is y equals 2x plus 3. Y is greater than 2x plus 3 would be everything above that line. But everything above this line, all this stuff here, that is all greater than y equals 2x plus 3. What if we have, and this is on page 282, step it out, number 3 in the textbook. We have y equals 4x plus 4, and we have y equals x plus 5. Okay? Okay. Let's make a graphity poo. And 4x plus 4. So let's go up by 3s. 3. Oh my goodness. 3, 6, 9, 12, 15. And then we'll do the x-axis by ones. Just to be crazy. Crazy! 4, 5, 6, and 7. So this would be negative 3, negative 6, negative 9, negative 12. Down here we have negative 15 if we need it. Then we have negative 1. Whoops. That's negative 1. Negative 2. Negative 3. Negative 4. Negative 5. Negative 6. Negative 7. And now we'll just continue on. Beep, beep, beep. Beep. Beep, boop, boop. Ooh, that was cool. Move you over there. Whoa, craziness. Beep, boop, boop. Okay. So we have these two thingies. And once again, this is page 282 in your textbook. Step it out. Number 3. All right, so y equals 4x plus 4. So 1 times 4 is 4, plus 4 is 8. So halfway between, not halfway, that would be weird. 6, 7, 8. We'll be about there. All right. Negative 1 times 4 is negative 4, plus 4 is 0. And then let's do negative 9. It's way too much. Negative 4 times 4 is negative 16. Plus 4 is negative 12. And let's do one over here. 3 times 4 is 12, plus 4 is 16. So that would be right here at the tippy top. All right, so then we'll draw our line. That's horrible. 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 Draw our line. Still not perfect, but you get the idea. So this line is 4x plus 4. Then we're going to do, let's do a red line. No, a green line. Let's do a green one. X plus 5. X is 0 plus 5 will give us 5. Be somewhere around 3, somewhere around here. 1 plus 5 is 6. Be right there. Negative 1 plus 5 is 4. So that'll be like, I don't know, around there. 2 plus 5 is 7. So that'll put us around there. 4 plus 5 is 9. That puts us right there. What did I do wrong? 2 plus 5. Oh. Geek. 2 plus 5 is 7. 6, 7. That would put us somewhere around here. That's much better. And then negative 3 plus 5 is positive 2. So that would put that somewhere around here-ish. We get the idea. Let's draw ourselves a line. Obviously my dots are not exact because I'm not using a very good scale. However, you get the idea. And this one is y equals x plus 5. Y equals, go back to black, y equals. So now we want to know the system y is greater than or equal to 4x plus 4, and y is less than or equal to x plus 5. So here's our x plus 5. Less than or equal to is going to be everything below that green line and including that green line. Everything down here. Y is greater than or equal to 4x plus 4. That is going to be everything up here. So the only part that satisfies both of those things is going to be, let's see, we used green and black, so let's use blue. This part in here. All of this stuff satisfies those requirements because this is all less than or equal to x plus 5, and it's greater than or equal to 4x plus 4. So all of this going all the way back, you know, we could keep going back down. But all x, we're on page 283, number 4, the green number 4 on page 283. X plus y is greater than or equal to 8. 5x plus 2y is less than or equal to 30. So the first thing we want to do is make our graph. All right, x plus y greater than or equal to 8. So the first thing we're going to want to do is solve this for y equals. So this becomes, we just change this greater than or equal to equals. Y equals 8 subtract the x from both sides, minus x. And this one becomes 2y equals 30 minus 5. Write out the 2, write out the 2. Y equals 15 minus 2.5x. Y equals 8 minus x. So 8 minus 0 is 8. 8 minus 2 is 6. 8 minus 4 is 4. 8 minus 6 is 2. And we begin to get the idea. 8 minus 8 is 0. Right? And then this one is y equals 15 minus 2.5x. So let's do 15 minus, we'll start with 2. 2.5 is 5, that's 10. So that gives us 10. 4 times 2.5 is going to be 2.5 plus 5 is 10. So 15 minus 10 gives us 5. Oh my goodness. I didn't change colors. So, and my dogs are going crazy. $15 minus 5 is 10. That's right there. 15 minus 10 is 5. That would be about in the middle of there. 15 minus 15 would be 0. So now we just draw our lines. Let's go back to the black and to the line drawer, and we'll say there's our line. We'll go back to the green and our line drawer, and we'll say there's our line. All right, so now we want anything that is greater than the black one right here. Let's go for red. Greater than the black line or equal to, and less than or equal to the green line. So that's going to be everything in here. Page 285, number 19. It gives us x is less than -5, x is greater than 2. So we will take and draw these. All right, we'll change that to equal to. Erase. X is equal to -5. All right, so for x is equal to -5, this is our x-axis, this is our y-axis. X equals -5. So this whole line right here represents x is equal to -5. So for x is greater than -5, it would be everything on this side of that line. All right, so then we have x is less than 2. 1, 2. Buckle my shoe. 2, So again, we're going to want to do equal to x equals 2. So we'll take this line right here, x equals 2, and on this line, this is the x value, it's 2, the whole line, right? So then, to satisfy this system of inequalities, something that x is greater than -5 and less than 2, it would be anything in between those two lines. 29. This is on page 285, number 29. It gives us x is greater than or equal to 0, y is greater than or equal to 0, and 6x minus y is less than 12. So let's draw our axis. Boom. Boom. Y, x. All right, so y or x is greater than 0. So we would draw x equals 0. Well, x equals 0 is the y-axis, right? So let's go ahead and we'll make that red. That is x equals 0. Our y-axis is x equals 0. Not what I wanted to do. Meek, 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 meek. Boink. Oh my goodness. Guys, what is going on with me? I am not being good at changing colors. There we go. That is 0. And we'll say, what is the other one? We have 6y minus, so let's before I put a scale on here, let's do this. Y equals 0, which that is going to be our x-axis. Let's make that green so we can be all Christmassy. Make it a line. On the x-axis, y is always equal to 0. So it's giving you your two axes for two of your three systems. And then your third system, go back to black. Negative y equal to 12 minus 6x. So y is equal to negative 12 plus 6x. I apologize that my doggies are being butt faces. Neighbor's doggies are barking and I have the windows open. Makes my doggies want to bark back. You know how it goes. So y equals negative 12 plus 6x. So let's see. Yeah, that'll work. 1, 2, 3, 4, 5, and the top is 6. 6, 5, 4, 3, 2, 1. Negative 1, negative 2, negative 3, negative 4, negative 5, and the bottom is negative 6. Then we have 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So y equals 12, negative 12 plus 6x. Negative 12 plus 0 is going to be way down there. Negative 12 plus 6 is going to be negative 6. So we'll go to, let's call it, we used red, we used green. I don't know if yellow will show up. Let's try yellow. Does that show up? Yeah, kind of. I don't like it though. Yellow makes me nervous. Guys, I want you to be able to see this. So we already used those, so let's just go with blue. Blue's handy. So negative 12 plus 6 times 1 is negative 12 plus 6. That is going to give us negative 6. And I went red. I meant to go blue. Negative 6. Negative 12 plus 6x. If x is 2, that's negative 12 plus 12. That gives us 0. So at x is 2, we have 0. Then negative 12 plus 6 times 3 is 18. Will give us positive 6. Boy, that barely fit. Go back to our line, and we're going to say Krakow. So we want something that x is greater than or equal to 0. So it's got to be above, or it's got to be to the right of this red line. And red going to be to the right of that, because this is our x is 0 and we want it to be greater than or equal to. So including it and to the right of it. Y is greater than or equal to 0. So go to our green. So it's got to be up here. And 6x minus y is less than 12. Less than. So that's going to be over here. So it's actually going to be, and I'll use yellow against my own better judgment, it's going to be this part right there. So this is both greater than or equal to, x is greater than or equal to 0, and y is greater than or equal to 0, and for a bonus, 6s minus y is less than 12. So it would not include this line right here. I kind of drew it to where it looks like it includes that. But it would not include that line, right? Because this is not a less than or equal to, it is a less than. Big craziness, right? That's as far as we're going this week. That's it. So, thanks guys. I appreciate you listening and being here, and I just appreciate you in general. Love you guys. Bye.